Assalamu alaikum everyone. Welcome to Maths Magic Hub. In this video, we will look at some examples on the vector equation of line. Example 1. A line passes through the point with position vector 3i unit vector minus 2j plus 4k and is parallel to the vector I minus j plus k. Find part A, the vector equation of the line. Well, in part A, we have to write the vector equation of this line. Let this vector be the A vector and call the direction vector as B vector. The vector equation of the line is R vector equals to A vector plus T times B vector, where T is some parameter. Reference for this equation is lecture 1. Okay, by just plug in the values of A vector and B vector to find the vector equation. Here A vector is 3i unit vector minus 2j unit vector plus 4k unit vector plus t times B vector is I unit vector minus j unit vector plus k unit vector. So this is the required vector equation of the line, or we can write it in column vector form as r vector equals to 3 minus 2 4 plus t into 1 minus 1 1. Note that both the forms are acceptable. So if someone write in the ijk reference unit vector form or in column vector form, both the forms are accepted in exams. Part number B. Well, in part B, we have to find the parametric equations of this line. The parametric equation of the line can be calculated as, here r vector is the position vector of an arbitrary point p xyz on the line. So r vector can be written as xyz is equal to 3 minus 2 4 plus t times 1 minus 1 1. Now collecting the like components on the right hand side, we can write this equation as xyz is equal to 3 plus t minus 2 minus t and 4 plus t. By equating like components, x equals to 3 plus t, y is equal to minus 2 minus t, and z equals to 4 plus t. So these are the required parametric equations of the line. Well, reference for this part B is lecture number 2. In lecture 2, we already discussed how to write the parametric equations of a line. Now, next example number 2. So, in example 2, the position vectors of the points A and B are given by A vector equals to 3i unit vector plus 2j minus 7k and B vector equals to I unit vector minus 4j unit vector plus 8k unit vector respectively. Part number A, write down the vector AB vector. Well, in part A, we are given the position vector of 2 points A and B, and we have to write the vector AB vector. We know that AB vector is equal to B vector minus A vector. So just plug in the value of B vector, that is I unit vector minus 4j unit vector plus 8k unit vector minus A vector is 3I unit vector plus 2j unit vector minus 7k unit vector. Expanding the second bracket, we get I unit vector minus 4j plus 8k minus 3I unit vector minus 2j unit vector plus 7k unit vector. Now combining the like components, we get I minus 3I minus 2I unit vector minus 4 minus 2 minus 6j unit vector and 8 plus 7 15k unit vector. So this is the required AB vector in this case. Part B. In part B, find the vector equation of the line. Well, for the vector equation of the line, reference lecture is lecture number 3. Here we are given position vector of 2 points on the line, and we have to write the vector equation of the line. So the vector equation of line in this case is r vector equals to a vector plus t times ab vector. From lecture 3, we know that this equation can also be written as r vector equals to b vector plus t times ab vector. So here we use a vector as the position vector of the fixed point on the line. So r vector equals to a vector is 3i unit vector plus 2j unit vector minus 7k unit vector plus t times ab vector is minus 2i unit vector minus 6j unit vector plus 15k unit vector. So this is the required vector equation of the line. In this case, we may also write this equation as a column vector, like r vector equals to 3, 2, minus 7 plus t times minus 2, minus 6, 15. Both the forms of the equations are acceptable. You may write your answer in terms of reference vectors I, j, k, or in the form of column vectors. Example 3. In this example, show that the line through the points with position vectors 9i plus 2j minus 5k and I plus 7j plus k is parallel to the line r vector equals to lambda times 16i minus 10j minus 12k. So in this example, we have to show that the given two lines with the given information are parallel. In lecture 3, we state a magic point that two lines are parallel if their direction vectors are parallel. So first we will find the direction vector of the two lines. Let us call the given vectors as a vector equals to 9i unit vector plus 2j unit vector minus 5k unit vector, and b vector equals to I unit vector plus 7j plus k. Now the direction vector of first line is direction vector of line 1 is, let us call it as c vector. C vector equals to b vector minus a vector. One may find it by subtracting b vector from a vector. Since any vector parallel to the given line is the direction vector of the line, so we can find it as a vector minus b vector. Okay, well, expanding the bracket, we get I unit vector plus 7j plus k minus 9i unit vector minus 2j unit vector plus 5k unit vector. Now collecting the like components, minus 8i unit vector, 7j minus 2j plus 5j unit vector, and plus k plus 5k plus 6k unit vector. Okay, well, and the direction vector of the second line is, since the second line is given in the form of r vector equals to a vector plus scalar times direction vector, so we can directly state the direction vector of second line, that is, say d vector equals to 16i unit vector minus 10j unit vector minus 12k unit vector. Now from lecture 3, these lines are parallel if the direction vectors c and d are parallel. And we know that two vectors are parallel if they are scalar multiples of each other. So d vector can be written as minus 2 times minus 8i unit vector plus 5j unit vector plus 6k unit vector, which is equals to minus 2 times c vector. As d vector is a multiple of c vector, which means this implies d vector is parallel to c vector. As direction vectors are parallel, hence the given lines are also parallel. That's it for this video. For getting more videos, do subscribe Maths Magic Hub. Thank you for watching. Hope to see you in next video.